All right, this is question 3 from AP Calculus AB 2022 free response question. All right, number 3, part A. Here we've got this function f of x, and then we've got this, we want to find f of 0 and f of 5. So again, this is f prime. I said f a moment ago, my apologies. And so how do we find f of 0? Well, this is where the fundamental theorem of calculus comes in. So to find f of 0, what we do is we involve the integral 0 to 4 of f prime of x dx equals f of 4 minus f of 0. Now they tell us what f of 4 equals, so we can plug that number in. Now f of 0 is what we want to find. So that's going to stay as f of 0. But the integral of this, well, we have to find this area. So this is a quarter circle with a radius of 2. So we have 1/2 pi times 2 squared. So that's going to be 2 pi. So when we subtract the 3, we get 2 pi minus 3 equals negative f of 0. So when we switch that around, 3 minus 2 pi equals f of 0. Now we set up the same way for f of 5. The integral from 4 to 5 of f prime of x dx equals f of 5 minus f of 4. So here again we fill this number in. F of 5. Now we have to find the integral from 4 to 5. So that is this area right here. So this is a triangle, base of 1, height of 1. So this is 1/2. So we add 3, and that means we get 7/2 for f of 5. And that is part A. Part B, find all x coordinates of all points of inflection of the graph of f. So we have points of inflection of f. So the question is, what's happening at that same time for its derivatives? So when f has a point of inflection, f double prime changes sign. Now what's happening with f prime at that same time? Well, that means f prime has an extrema. So where are the coordinates where f prime, the graph we have, has an extrema? Well, that's going to be right here at x equals 2, and right here at x equals 6. At x equals 2, and so how do we justify this? Well, we say this because at f of 2, f prime of 2 is negative 2, but f double prime of 2 is 0. And we can also say f prime of x is less than 0 when x is less than 2. So for all of these values over here, f double prime is negative. But then after this, f double prime is positive for x. That's for 2 greater than x greater than, and we only need to concern ourselves with 4. Now over here, same thing. X equals 6. Now here, f double prime of 6 does not exist, but it is still a point of inflection for f because it changes sign. Why? Because f prime of x is greater than 0 for 4 less than x less than 6, and f double prime of x is less than 0 for 6 less than x less than 7. Part C. So now we have a new function, g of x, and we want to know on what intervals is g of x decreasing. Now g of x is going to be decreasing when g prime of x is less than 0. So that means g prime of x is going to equal f prime of x minus 1. And we want that to be less than 0. So we want when f prime of x is less than 1. So the question is, when does that happen? So let's draw ourselves a nice horizontal line right here at 1. So we're looking for all of these values here when it is less than 1. So we have the interval 0, less than or equal to x, and we include 0 because it is less than at that point. And then less than 5. It's not, we don't include 5 because it's equal to 1 at that point. And then finally, letter D. For the function defined in part C, what is the absolute minimum value for g of x? So now for g of x, we have to consider where is it have a maximum or a minimum. Now, sorry, what is the absolute maximum? Minimum. So we have x and we have g of x. So we always consider the endpoints. So we have to consider 0, we have to consider 7. But then what about any extrema for g of x? Well, extrema is going to happen whenever g prime switches signs. So if we think about it, g prime of x equals f prime of x minus 1. And so that is going to change signs at 5. Now it also equals 0 at 7, but it's at the end of the interval, so we don't have to worry about that. Now it's negative over here before x equals 5, and then it's positive between 5 and 7. So we also have to consider x equals 5. So now, in order to find this interval, we have to figure out, okay, how do we find these values for g of x? Now, do they give us any other information other than that? Well, they don't give us a point like they give us for f. So how are we supposed to figure out if we don't have any of those numbers? Well, they tell us that g of x is f of x minus x. So they actually do give us a point. They tell us that f of 4 equals 3, so that means g of 4 equals f of 4 minus 4. Now f of 4 equals 3, so 3 minus 4 is negative 1. So there's our starting point. So that's how we can consider what the values of g of 0, g of 7, and g of 5 are equal to. All right. Let's add a page. Okay. So now, how do we get these values for the absolute minimum of g of x? Since we already have g of x, but it also is going to depend on f of x. So x equals 0. So that means that we're going to find x equals 0. We're going to go 0 to 4. G prime of x equals g of 4 minus g of 0. Now, on the left-hand side, we have f prime of x minus x dx equals, now g of 4 is negative 1 minus g of 0. Now we can break this integral up, 0, 4, f prime of x minus the integral of x dx, negative 1 minus g of 0. Now the integral from 0 to 4 of f prime of x, well, we found that. Where did we find that? I think we found that back in part 1. Yeah. That integral is 2 pi. So 2 pi minus, now the integral of 0 to 4, well, that's 1/2 x squared from 0 to 4. So we plug in 4 squared is 16, half of that is 8, equals negative 1 minus g of 0. So I add 1, so 2 pi minus 7 equals negative g of 0. We'll switch that around, 7 minus 2 pi equals g of 0. So there's our value for 0. So let's now find, similarly, for x equals 7. So we have 4 to 7, g prime of x dx, g of 7 minus g of 4. So 4 to 7, f prime of x dx. Now we'll just separate out the integrals from the start. X dx equals g of 7 minus negative 1. So now here I've got to find the integral from f prime from 4 to 7. So I have to go back up to here. So from 4 to 7, this square is 1, this triangle is 2, this triangle is 1/2. So that's 3.5 or 7/2 is an improper fraction. The integral from 4 to 7, so this is 1/2 x squared, 7 and 4. So we have 49 over 2 minus, and we'll just leave it as 16 over 2 just so we have a common denominator, equals g of 7 plus 1. So 7/2 minus 49/2 plus 16/2 minus 1 equals g of 7. All right, so let's see. 7 and 16 make 23 minus 49. So that is going to be, so if we switch that around, that's just going to be negative 26. So negative 26 over 2 minus 2 over 2 is negative 28 over 2, which is negative 14, equals g of 7. And then finally, g of 5. So x equals 5. So from 4 to 5, we have g prime of x dx equals g of 5 minus g of 4. So we'll break up the integral 4 to 5, f prime of x minus the integral 4 to 5, x dx, 5 plus 1. Now also, from 4 to 5 of f prime of x, we did find that way back in part A. Yep, there it is, 7/2. All right, so 7/2 minus, all right, so 1/2 x squared 5. So 25 over 2 minus 16 over 2 equals, and let's not forget to bring over the 1, minus 1 equals g of 5. So 7 halves minus 9 halves minus 2 halves equals g of 5. So that's negative 4 over 2, so I have negative 2 equals g of 5. So what is our absolute minimum value? That value is negative 14, and you pretty much have to find all three of those values in order for AP to give you the credit for justifying your answer. If you like this video, give it a thumbs up. If you think I made a mistake, you see something I made incorrectly, or if you've came up with a different answer, let me know in the comments. Thanks for watching.